Welcome to project number 2, solar panel design for Engineering 100. This is Robert Mitchell. In this video, I'm going to proceed down the format of project number 2, solar design document. I've already covered in another video the solar panel design requirements, and now I will do the solar panel format. In this format, it is already established. It's a title page. The title page has photovoltaic system design. Down at the bottom, a location for the designers, team members to put their names on the document. Remember, when you do that and submit it, the team member doing the submission is to highlight their name on the report. Then we have a table of contents. We have an executive summary, a project information, roof panel before and after, data and calculations, utilities, solar application, one-line diagram, solar bill information, conclusion, and references. In the other video, we went over the points that are associated with each of the sections. In the executive summary is one page. It's to have basically 4 paragraphs. The first paragraph is a summary. The next 2 paragraphs are information about the design, and the last paragraph is a summary which includes cost of the project to the customer. Then we move on down, and the next page is project information. This is basically restating what the assignment is, and that's an assignment for a client's solar system. We have the home information, an aerial view. Again, gives you the roof azimuth for pointing south, and the pitch on the roof of 22.5 degrees, the information about the customer's utility bills and the 11,326 kilowatt hours. You have the roof plan before, already gone over in the assignment, and then you have it after, and your requirement is to draw your panel in the area that you intend to put your panel array or arrays. It could be that you have to do more than one. Moving on down, now we have calculations. These are simple little calculations used to determine number of panels in designated areas. Where do you get the information for the designated areas? From your roof plan before. In doing these calculations, the first thing you need to understand and determine is your panel square footage. So let's, for the sake of working this problem, let's assume that your panel is 3 feet by 6 feet. So that's 3 times 6, it's 18 square feet. Now let's go for the area. The area we're going to look at is back up here. I come back to it. 12 foot 8 inches and 12 foot. So I come back, I put 12 and 8 inches is 0.67 by 12 feet. And when I calculate that out, that comes out to 152.04 square feet. But now I want to take that and I want to divide by the 18. So I put 18 square feet. And when you do that division, the number of panels comes out to be 8.4467. Do you have such a creature as 0.4467 panels? No. Because we're looking for the total number of panels, you would then use 9 as your number. So now that we have the number of panels, we can proceed on with determining the array total size and output. Now, the total requirement for the customer is 11,326 kilowatt hours. Our panel output for this, we're going to say, is 270 watts. So we then will go over to our NREL website. Before I run over to the website, though, let's get a little more information. We know the watt output. Now we need to add tilt and azimuth. So we jump back up to our drawing, and the azimuth is 162.98 for due south. However, we're facing 90 degrees, so that's 162.98 plus 90.8. So let's go back down to our calculations, and the tilt is 22.5 degrees. The azimuth is 252.98. Now we can go over to our NREL calculator, and that calculator can be found at pvwatts.nrel.gov. It comes up to this calculator starting point, and to get started you need to enter an address. Well, in this case we know that it is zip code of 88001. We click on go. So it gives us a latitude and longitude. If you go down and look at the map, Las Cruces. So we go to the system information. Here's where we need to rethink the calculating decision. Instead of 4 DC system size, we're looking at 1 standard. It's not a fixed open rack, it's a fixed roof mount. 14.08. The tilt is not 20 degrees, it's 22.5. And the azimuth is not 180, but the azimuth angle is 252.98. Oh, it didn't go in there, so let's try it again. 252.98. There we go. Click on the orange arrow to the right. We now see that the total output is 1,574 kilowatt hours per year. We have all of the data down at the bottom. This is where you using the print results comes out to be important, as the screen print will only print this information, and for your report you have to have the entire. So the print results icon will allow you to either print it as a page, which you can then scan as a PDF, or you can go straight to a PDF. You need to understand how to do that, and that's where you might have to get some help. So now that we know 1574, let's go back to our report. We said the panel is 270, and the NREL estimated for our 1 watt system came out to be 1,574 kilowatt hours. We come down and we put A to, notice it's A, B, C. Well, A is 11,326 kilowatts hours, and we're dividing it by C, which is 1,574 kilowatt hours. That's our NREL calculation. When you run that division, you come out with 7.20 kilowatts. We now run down to the number of panels. we enter the 7.20 kilowatts divided by our panel size, which is 270 watts. But we're doing kilowatts and kilowatts because we wanted just a number. So you divide it by 1,000. When you do that, you come out with 26.7 panels. Again, there are no 0.7 panels, so it says we need a total of 27 panels. However, we calculated the biggest area, or that little small area would only handle 9, so you would need to go back and calculate a larger area from your house plan. I will let you do that. You put the same calculations in here, that square footage, divided by the 18, you'll come up with the number of panels that would fit in that area. If that number plus the 9 gives you the 27, then you're great. And that would be 18, by the way. And then once you have all that, you now know what your panels, so you can draw your panel arrays on the roof plan. Once you have the panel arrays, then you need utilities application. So you complete this. Remember, your inner customer is your instructor. Maybe a lot of information that you have to make assumption on, but go ahead and fill it out. Here's your one-line diagram. Your one-line diagram, type, watts, inverter, watts. Come on down, solar panel information. And on this page, you replace this line with Excel spreadsheet, being sure to adjust spreadsheet to fit on the page. I will not go through that at this point, but that's the Excel program, or worksheet that you have to calculate. And then you have conclusions. But you would also need to insert back up here utility solar, not the application, but in the information, after you do your array total size and output, you'll want to do additional inserting of your web page for your array. I mean, not your array, but your panel. You can get that from the web page that is directed in the assignment. Any other information necessary, your cost estimate goes in here. And then you write your conclusion. All of that is in your references. All of that is identified in the assignment. So that's going over the format for the report.